Consider a compound microscope which works by shining light through a thin specimen and projecting the image to the viewer. If the object is large, it will be observed in a couple of serial sections. If the object needs to be measured for analysis, then one has to reconstruct the 3D image. The projection of images and reconstruction is important in understanding many concepts in science. This practice is known as stereology, which involves interpreting 2D images from sections of a 3D object to determine its 3D shape. The module we have created allows middle school and high school students to begin to understand how scientists might construct a 3D image of a cell or nerve synapse within a nerve terminal based on 2D slices of the specimen.
You want to try that one again?
Yeah.
Okay.
The module we have created allows middle school and high school students to begin to understand how scientists might construct a 3D image of a cell or synapse within a nerve terminal based on 2D slices of the specimen. By constructing slices of a specimen from Tupperware containers and styrofoam, teachers can create an interactive module for students to follow a similar process as scientists would. Students will take measurements of the styrofoam inside the Tupperware, considering that this is their specimen. By recording those measurements and following a detailed set of instructions on provided worksheets, they will begin to see that the measurements they take and the actual measurements. I'm just going to say that sentence again.
Yeah, okay.
Well,
You want me to move it?
Yeah. There you go.
Is that okay?
By recording those measurements and following a detailed set of instructions on provided worksheets, they will begin to see that the measurements they take and the actual measurements are not nearly the same. Thus, we introduce error calculations. Students will see that by adjusting the measurements they have taken, they will gain an overall area measurement closer to the actual area of the specimen. For a more advanced level, we have introduced volume measures of the objects and the associated volume in reconstruction of the 2D slices. Geometric to calculus-based problem sets are readily available to be introduced.
Is that this one?
Application of knowledge to real-life problems and authentic scientific inquiry with active learning processes, along with construction of various types of models, is a focus for the next generation science standards. In addition, applying multiple disciplines and cross-cutting concepts integrating algebra and geometry in relation to stereological issues is of importance in appreciation of mathematical application to biological topics. By integrating mathematical and biological concepts, we help students understand the underlying concepts behind stereology and scientific investigation. We hope you find the module informative and effective and welcome any questions you may have about our project.